Hello, we are on section 10.1 and 10.2. This is about angles, right angles, trigonometric ratios. We're going to start out with radian measure. And so we're going to talk about how radians are related to degrees. And this is going to be something where you have a formula to convert from radians to degrees or degrees to radians. And so as you can see in this this part right here, 1 radian is 180 divided by pi, which is about 57.296 degrees. So we usually say about 57 degrees is 1 radian. Now the radian is the angle at the center of the circle, which you can see here. And so it's got its angle right there at the center of the circle, and so the 1 radian is about 57 degrees. In fact, in a full circle it's about 6.28 radians. Now this is our formula to go from radians to or from degrees to radians. Let me say that the right way. So if we have degrees, to get to radians, we're going to multiply the number of degrees times pi and then divide it by 180. Now you want to try not to get too bogged down with this. It's just two different ways to measure angles, degrees or radians. You will have these formulas on your formula sheets. You don't have to memorize those or anything. And so let's do a little bit of converting here. So we're going to write the following angles in radians. Okay, so we're going to use this formula up here where we multiply our angle measure in degrees times pi and divide by 180. Notice we're going to round to the nearest hundredth, so 2 places after the decimal. And this is just a calculation with your calculator, right? 185.8 times pi, and then divide by 180, and that's about 3.24 radians. Now we can abbreviate that as RAD for radians. Same thing on the next one. Now you can go ahead and calculate this yourself. Make sure that you're good with the calculations. So try this out on your calculator before I give you an answer so that you can make sure that you're on track with that. And this one is going to be about 0.17 radians, because that's a real small degree angle or degree measure, right? Now this next one is a mixed number degrees in degrees, and you can change the 5/8 by just taking 5 divided by 8, or you can key it in using your fraction key. Whoops. I was trying to draw a line across there. So we're going to multiply by pi and divide by 180. So be sure that you try this on your calculator. 5/8 is 0.625 as a decimal. And so if you want to put in 68.625, then you can certainly key it in that way. And this one ends up being 1.20 radians, and when we round it to the hundredths place, we have to put that 0. I didn't have it written down what that was before rounding, so let me check that. Whoops. Oh, and I cleared it. Okay, so 1.197, so that ends up being 1.20 when we round it to radians, or to the hundreds. I was looking at the RAD. Oh, this is the way it goes sometimes. Okay, so now we're going to go backward from that. We're going to convert our radians into degrees. And so then we have this other formula. Notice it's kind of upside down from what the one was before. So we take the number of radians and we multiply by 180 and divide by pi. So once again, it's just a calculation. And this one is about, we're rounding to the hundredths place again, So about 48.13, and now this one's degrees. You want to make sure that you label your answers always. With almost everything we do, we need a label. I can't think of very many things where we don't. And we have a few of these trig ratios where straight calculator work that we might not have to label. Okay, so next we're going to take 3.5 radians, multiply by 180, and then divide by pi. Hopefully you guys are getting really good with formulas. When we round it, it is 200.54 degrees. Okay. Next, now we've talked about these radians and angles because we're now going to talk about the arc length and the area of a sector. Now, a sector is a wedge-shaped portion of a circle. So it looks like a piece of pie, looks like a piece of pizza, that kind of thing. Oh, this silly thing keeps doing weird stuff. All right, I'm back when I'm trying to get this to quit doing this thing that it's doing, and I don't know why. Okay. All right, I think I got that fixed. Norton was trying to do something there. Okay. So on this one, we are going to use formulas again. Now the arc length is this part right here. So of this sector, we have a distance, right? It's really this right here, this part of the circle. I can't seem to draw on that. But anyway, we're finding the length of that part of the circle. So it's basically part of the circumference, if you think about it that way. And then the area of the blue part, right, that wedge, is 1/2 times the radius squared times A. Now, A is our central angle in radians. Most of the time you're going to be given your measurement in degrees, so you have to use that formula to convert it to radians first. And then we can work the formula. So you've got to be careful with this because it doesn't really say this. I think it says it on your formula sheet that the A is the central angle in radians. So beware there. Because if you don't use the radians, then you don't end up with the answer that you need here. Okay, so on this, it's one is sheet metal worker wants to know the arc length and the area of a sector with central angle 150 degrees cut from a circular sheet of metal with radius 16 inches. Okay, so we want to start out with A. We need to figure out A. Well, A needs to be in radians, so we're going to take the 150, right, or 150 degrees times pi and divide that by 180. Now, some people want to use the decimal on this, and I personally don't like to because you have to write out a whole bunch of places after the decimal to make sure you're accurate. If I simplify the fraction 150 over 180, that is 5/6. Now, do you remember how to do that? Maybe, maybe not. All you have to do is use your fraction key, put 150 over 180, push equals, and it simplifies your fraction for you, and you will see that it's 5/6. So it's 5 times pi divided by 6, and that's the number of radians that are equal to 150 degrees. Now, my radius is just 16 inches. I'm getting tongue-tied there. All right, so we're going to find S, which is our arc length, and let me write that formula down. So, oops. S is the radius times A. So we just figured A, right? There's my A. And here's my radius. I simply multiply that and I know my arc length. So I take 16 times 5 pi divided by 6. And really the main thing here is just be careful with your calculations so you don't mess it up, right? That's really the only place here where you're going to, if you get everything in the formula, then it's just a calculation. So my arc length is about 41.9 inches when I round. and we are rounding, let's see, I don't think I told you on this one, so we're just going to go to the 16 inches was 16.0. We'll just go to 3 significant digits on this one. And then for A, my area is 1/2 times the radius squared times A. So just get everything substituted in. My radius is 16. I'm going to square that and multiply it by the A. And you can calculate this all in one calculation if you want to. I'm going to do an in-between one. So if I take 1/2 times 16 squared, which 16 squared is 256, and I get 128 times 5 pi divided by 6. And that is about 335 inches, and this is square inches because it's area. So all area is in inches squared, feet squared, units squared. And so you just have to remember how to label that. Arc length is a length, so we just do inches. Area is in square units. All right. We'll see if we can get part of this problem done. I'm not sure how far we can get. Okay, the outfield fencing for a Little League field forms a circular sector with home plate at the center. The fence is placed at a uniform distance of 215 feet from home plate. The boundaries of the fence, which extends partway into foul territory, create an angle of 105 degrees with home plate. At $28 per foot, how much will the fence cost? Round to the nearest $10. Okay, that was a lot of information, right? So you might want to pause the video, go back and read through it again. I'm going to write the 105 here, right? That's 105 degrees. And on this one, we're finding arc length because we're finding the fencing. So you see this blue part going across here. That's the length of my fencing, which is the arc of part of a circle, right? The arc of that sector. And then my 215 feet, you see, is on each side here. So that's going to be the radius. So once again, let's find our A. I'll put that over here this time. Okay. So it's 105 times pi divided by 180. If you simplify that with your calculator, remember 105 over 180 simplifies in this case to 7/12. And then we still have the pi, and that's the number of radians. That's what A is equal to for this formula. Then my radius is 215 feet. Now it's just a matter of substituting in and finding my arc length. Remember that is the radius times A, and A is 7 pi over 12. I'll write that up here. And then we calculate. Okay, so just take 215 times 7 pi divided by 12, and I find an arc length of about 394 feet. And it's $28 per foot. So then I need to find my cost, right? 394 times 28, and that gives me 11,032. And there's not much rounding we have to do there because we're going to the nearest $10. This was in dollars, right? So $11,030 is what that fence is going to cost. Okay, so we're going to finish this problem because it's a two-part problem. The next part is on this next page, and we're going to do some things with the area of the sector. All right, so I'll pick this up on the next video.